couple concepts I think we need to talk about right about now. And these concepts were introduced to us by Albert Einstein, and it's special and general relativity. Let's talk about general relativity first. And I got this graphic from NASA, and basically it illustrates general relativity. General relativity is about bendy space. And the only thing I have with this particular graphic is that it suggests that the apex of gravity is right about here. And theoretically, it should be actually dead center of the massive object, which in this particular case is Earth. So how do we know that general relativity bends space and time as suggested by Albert Einstein? Let's talk about space bending first of all. And basically it's illustrated by a guy called Arthur Eddington. And what he illustrated was that light actually bends. It's called gravitational lensing. And basically what he did was he isolated a star that was supposed to be over here. But what happens is that as the light travels towards, it bends towards the sun and then continues in that trajectory. And when you observe the light from Earth, it actually looks like it's actually over here. Now the difference between the observable star and where it should be could be explained through the equations derived from general relativity. So that's how we know that space actually is bent by objects, and the effect is gravity. But how do we know that time is also distorted by the gravitational effects of an object? For that, we look at the concept of gravitational time dilation. And basically, if we had two clocks right by the equator, and these are atomic clocks, and basically, if you put these atomic clocks side by side and 100 years go by, if they're in sync, 100 years later, they will have the identical time. But if we take one of these clocks and we move it to a satellite, and we do this with GPS satellites, for example, they have like 3 or 4 atomic clocks on them. So we know that this actually happens for real. The clock here will actually speed up in time relative to this clock here. And the reason being is because the closer this clock is to the center of Earth, the more the Earth gravities affect time. So this clock here, if it's on that satellite, actually gains about 10 milliseconds per day. So that's how we know that a massive object, such as the Earth, would actually bend not only space, but also time. There's something else, general relativity. And because this satellite is traveling about 16,000 kilometers per hour, what special relativity says is that the closer you travel to the speed of light, the slower time goes. So in this case, it's actually losing 6 milliseconds per day. So the net gain is actually around 4 milliseconds per day. Now, if the GPS satellite loses 4 milliseconds a day, that could mean that the receiver will think it's in downtown New Delhi rather than downtown New York. So what happens is that the clocks on the satellite are synced with the clocks on Earth pretty well daily. But in the meantime, what happens is that the clocks on the satellite uses relativistic equations to correct the time so that it stays the same as those on Earth. So the next concept is spaghettification, one of my favorite things. And basically what it is that anytime you're falling towards an object, especially a very, very heavy object, there is something called a tidal force. And basically what the tidal force is just the gravitational difference between, let's say, you're falling feet first towards the object. The tidal force is the gravitational difference from your head to, let's say, your feet. And basically what's going to happen is that your head is going to be falling at a slower rate than your feet. And what that's going to do is basically kind of stretch you out. So what's going to happen is that your hips is just going to split apart and your torso is going to go that way, your legs are going to go that way. And then eventually the upper part of your leg will split off from the lower part of the leg, and so on and so forth. So basically that's the concept of spaghettification.